Previously, we discussed axiomatic concepts, and those axiomatic concepts dealt with time, mass, as well as position. Okay, and these concepts are great. They're awesome. Okay, we could talk about them all day philosophically. What time is, what mass is, what's position. All right, but now we want to be very formal, very specific. So we go to this abstraction known as a number line. And from this number line, we write tick marks. Now, each one of these tick marks are going to represent a unit of something, okay? So let's say that we start off with time. And we say, okay, we're going to define a second. We know what a second is going to be, okay? We can look at a watch, or we can look at the sky, and we can look at the moon, we can look at the sun, we can look at the celestial. We can do it like that, or we can take some atoms, and we can say, oh, this thing, it does A, B, and C in a given amount of time, and so we're going to define this as a second. And so what we have to do is we have to say 1, and I'm going to put 1 right here, and I'll put 0 right here, okay? And I'll put 2 right here and 3 right here. -1, -2, and a -3. And so we'll define this timeline, or this number line, as time. This is also considered something like a watch or a clock, okay? So it's a scale. It's a way in which we can measure, and we have this. We do this all the time. All of our mobile devices, our computers, the way we schedule things, we go to work at a certain time, we can measure these things, and we can all synchronize. That's really one of the powers of having this formal specificity. That's time, okay? We can look at the change. We could say, oh, well, we're going to start at, in 2 seconds, we're going to start. And then in 3 seconds, we're going to stop. So we can have something known as our time initial, and then we can have some time final. And between these two, we know that the difference between time initial and time final is just going to be 1 second. So if we define time initial this way, and time initial is 2 seconds, and then we define time final with this graphical representation, we know that that's 3 seconds. So we know that we have 3 minus 2 is just going to be 1 second, or 3 seconds minus 2 seconds is just going to be 1 second. So how is that really looking? Well, we're going to call that delta t. And delta t is going to be time final minus time initial. I don't want you to become overwhelmed with the symbols, but that's what I'm trying to say. I want to write those symbols so that we can move very fast. So again, time sub f is just the time final, and then time sub 0 is just the time initial. So you'll hear me speaking about that quite often, or delta t, okay? We'll actually move from both of those, and we'll just end up calling delta t, t. In other words, we'll always, or tf, and we'll say that tf is just t. We'll always pretty much say that our initial time is 0. Okay, so it's like we started at 8:30 and we ended our time at 9 o'clock. We know that that's 30 minutes. I could have just said, oh, let's start now, and then use a stopwatch and allow that stopwatch to spin. And when it stops at 90, it's going to be 30 minutes. When it stops at 9 o'clock, it'll be 30 minutes. All right. So what I want to do is I want to treat mass the same way as well as position. So if I just go ahead and bring this up, I can say, I can put 0, 1, 2, 3, -1, -2, -3, okay? And we can call this mass. So now this is a mass number line. And we do this. Where can you find a mass number line or a real world device that will represent this mass number line? Well, it's a mass scale. You see them at the grocery stores when you're measuring your your meat that you're picking up. The butcher typically does that. And then you have another scale when you pick up your vegetables and you want to weigh them. And then there's another scale at the cash register. And so they're checking the mass, okay? And based on the mass, that's how much you're going to have to pay for the item, okay? And so we can just use a quick example, and we could say that we have pizzas, and each pizza is a pound, okay? And so if each pizza is a pound and we order 3 pizzas, we know that we are located right here, okay? So that vector would represent 3 pizzas, even though you don't really represent mass as directional until you have mass and then you don't have it. But that's another story. It's like having $10, it's in your pocket. Now you have to give it up. Now it's not in your pocket. The direction is quite evident there. But when it comes to formal specificity, we don't need direction necessarily in that case. So we have this, and let's say your little brother is at home. You leave those 3 pizzas there. You say, I don't want you to mess with this. When you come back home, one of the pizzas has been eaten. Okay? So we measure backwards. So that means the resulting mass, which is just going to be delta M, it's going to be mass final minus mass initial. Okay? So when we look at this, it looks weird to me. It looks like it's going to just mess up. But our mass final is going to be like a -1. It's going backwards. Then our mass initial is like a negative or a +3. So our initial mass was 3. So now this thing is coming out to be 4. A -4. This would be incorrect. Totally incorrect. Okay? So if you start off with 3 pizzas and someone eats one of them, this is totally wrong. How do you think about this? Where did I mess up? So the first one, this should be mass initial, and then this should be mass final. Well, actually, that's not the mass final. Okay? Is that the mass final? And this right here should be the delta mass. Okay? But it's not. Okay? So I see how I'm thinking about it wrong. So it's not delta mass. This is actually the mass final here. And this is going to be delta mass, because we need to see the change between what happened initially to what happened in the final situation. So we already know that this thinking is incorrect right here. So let's put in our correct thinking. Mass final minus mass initial. This is going to equal to our mass final is going to be 2. Correct? And then our mass initial is going to be 3. So we end up with a -1. The change in mass is a -1, which means that someone ate a piece of pizza. It's like not a piece of pizza, but one of the pizzas is gone. Okay? So now you see that there could be trouble when you're trying to interpret what's going on, but this is how I am fixing it. And I want to leave this fix in here for you guys, so you'll know that you'll know how to think about things. All right, so now let's look at position. So we're considering this to be position. Again, I'll just put this here. Position. Okay, and we'll start off at 0, and we'll have 1, 2, 3, -1, -2, -3. So let's say we start at 1 here. Let's just do it the same way. We start at 1. Okay, and then we end up at 3. Okay, so we're going to take a delta x here, And now vectors are coming in, and we're going to call our first vector delta x. I mean, not delta x, but x initial. And we're going to call our second vector x final. So I mentioned vectors, and I haven't been very formal with it. You should be asking the question, well, what is a vector? A vector is something that has position, not position, it has magnitude and direction. That is what a vector is, okay? And so we are going to put x final here and x initial right here. And so when we do that, we can now do a calculation. We know that our final position is 3, and we know that our initial position is 1. So we only move 2 units to the right. Okay, so this is going to be our delta x. Okay, so if I say done, you'll see now that I am trying to measure each one of these with some kind of scale. We know that we have time here, and with time, we know that each one of these units is 1 second, 2 seconds, 3 seconds, okay, because we've agreed on that. We also know that for mass, this is going to be 1 kilogram, 2 kilograms, 3 kilograms, all right? And then for position, this is going to be 1 meter, 2 meters, 3 meters. Now, in this particular situation, I failed to mention the kind of scale that you can actually go and purchase. But the kind of scale that you can go and purchase is a ruler or a tape measure. And this will connect us all effectively as a team. I'm going to stop right there. And once I come back, when I come back, I want to get into vectors a bit more. I want to treat that a bit more.